Alright, so today we're going to be looking at the 5-number summary. So the 5-number summary, as it's stating there, is these 5 numbers, these 5 values there. So you should, when they ask you to do the 5-number summary, you should put them in order as well. So your minimum value, your Q1, your median, which is also known as the Q2, the Q3 at third quartile, and the maximum. Now, we saw in our calculators, you saw this is all listed where we found the mean and the standard deviation. They're all there, and if you scroll down, you can actually get the 5-number summary in view. All right, so what we're going to do, so obviously they're good key points of the data that we're looking at. So we could display the 5-number summary in a box plot. So a box plot is a display of the 5-number summary. Okay, so, and here when we have a box plot, so if we're drawing a box plot ourselves, we must have, this is a ruled number line. So it just means like an axis, and it's ruled and it's broken up evenly. So the ruled number line. And we obviously mark the certain points. So you can see the major box in the middle is where we can document. So Q1, this line here is the Q1. This line is indicating the median, and this line here is indicating Q3. Okay, so then what we would have is, so that we mark those, and you can see we create a box like that, so just by drawing them in. Now, the box will have different shapes. So sometimes maybe this start bit will be bigger than the second bit, and so on, or it could be vice versa. They might equal each other. And that's what we talk about when we're talking about the shape. We're talking about that part of the box plot in here, okay? So we then have extra little bits where we have the whiskers. So what happens there is a whisker draws up to the maximum value. That's not an outlier, okay? So maybe write that there. That's not an outlier. So if you have an outlier, we'll see in a minute, that's represented by a dot. And this was the minimum value. That's not an outlier. So if your data doesn't have an outlier, it would look like this box plot here. So as you can see, when you have this, I'm just going to draw another one here. So when we have the box plot, so remember we said about the median, and remember we said that 50% lies below it and 50% lies above it. So what happens actually is these sections here, so from the median to Q3 is 25%, okay? From Q3 to the end of the data is another 25%, and vice versa here, this is 25%, and that, is 25%. So you can see there all the quartiles. So if you're asking between Q1 and Q3, we have 50%, yeah? If we were to go from Q1 to the end of the data, we'd have 75%. Can you see I'm adding up the percentages? And so you may get questions like that, and you'll see that in a minute. Oops. Okay, so we've got the stem and leaf plot, and they've given us the 5-number summary already in a table. Now we're going to assume that this has no outliers. They often will tell you, because otherwise we'd have to go check, and we haven't at this stage learnt that. So we're going to say, write in brackets here, assuming no outliers. And so they're asking us to draw this. So I've got the number line there for you. So let's go through it. I often find it's better to do the middle box bit first. So if we go Q1 is 66. So if we look up there, it's about there. So get your ruler and rule a line. Then we've got the median is at 73. So use another little line, and Q3 is 75. So that's there. So if I draw it up like that, and then I'll add the whiskers in. So they said 52 was the minimum. So that would means the whisker goes all the way up to 52. And then the upper whisker, it's going to go up to 77, which is just about there. Okay. Oh, sorry, that's probably a bit too far. I'll go back a bit there. So 77. So you can see there, this one, so maybe this shape, it looks a bit different. This part of the box, that left-hand box, is much bigger than this box. So we're going to describe that in a shape. So that actually, I know looking at it, and you're going to see, you'll have a reference sheet, that is negative skewed. You know why? Because see how the long stretch of the red box there? It indicates like if you had a histogram, it would look like that, yeah? So the tail's at the front. If the tail's at the front, what would we describe that shape as? Negative skewed. Good. So this one is negative skewed. But we'll look into that in the following pages. All right, so we're going to do this on the box plot on your calculators. I'm going to pause the video and get you all to do this. So we're going to go into listen spreadsheets, and we're going to type in these two lists. We normally just do a box plot of one list, but you will get asked eventually down the track to do a parallel where we do a couple of them. So I'm going to show you now. Okay, so we had a look and we've seen this, and we've had a little look at the difference in these shapes. And let's continue on. All right. Okay, so we saw in our box plot, we saw that we had an outlier. So when we had a outlier, so we can have an upper outlier or a lower outlier. Now, we also saw them in our histograms, and we often saw it as it's floating out there. The good thing with a box plot, you can 100% know it's an outlier because the box plot demonstrates an outlier as a dot, where sometimes in a histogram we're not really sure. It might not have made it to be an outlier. So often when you're unsure, if you've got a set of data and you're not sure if it's an outlier, throw the data into the calculator and create a box plot, and then you'll know, you can hover over it, you'll know for sure which one's an outlier. So how do we know how does the calculator, how do we know? Well, we have a rule, and we create these fences. And so we don't have to draw that line, but it's a line, an imaginary fence. And if the number, this is the upper fence, and we have a calculation for it. And if the number, when you calculate this number, if any of the data is above that number, it becomes an outlier. And then we have the lower fence, and you have a calculation for it, and any number that's lower than that becomes a thing. So here briefly, they're saying this is the rule to explain. So that would be Q3, and this would be Q1. So anything below Q1 minus 1.5 times the interquartile range is an outlier, and anything Q3 plus 1.5 is an outlier. But just to make your life easier, here are the actual formulas for the upper and outer fence. So you don't, it's just explaining. Now you know that the IQR is Q3 minus Q1. So in the end, this is the formula that we can use, yeah? Because I'm just writing it all out. Instead of writing IQR, I'm actually going to put Q3 and Q1 in there. I think that's better to do on your calculator, because if you accidentally recorded the wrong number, we can just copy and paste it. All right. Okay, interpreting a box plot. So we've been given a box plot here. So when they've asked me to determine the few things. So the first thing is the median. So here, that line there is the median. So reading off, what do we think the median is?
37.
I reckon 33. Oh no, probably 36. Sorry, they're going up in twos, aren't they? Yep. All right, so we'll go 36. The Q1 and the Q3. So Q1 equals what? 30. And Q3, I think 44. Okay, so the interquartile range, when they ask me that, we know that's Q3 minus Q1. So you just said that was 44 minus 30, so that would be 14. And then it says, what's the minimum value? So that outlier is the minimum down the bottom. And what's that one? Maybe 2. And the maximum value is probably 91. Or what is it? 92? 92. Okay. The values of any possible outliers. So we just would be reading off the dots here. Because we have no other option, we don't have the lists of data. So we're just reading off the dots, and it should be fairly clear in an exam, even though this one might not be. So I'm going to say 270, is it 84 maybe?
Yeah.
And 92? Okay. So now, it says in F, so this is where we're going to test for outliers. So it says F, the smallest value in the upper end of the data that will be classified as an outlier. So the smallest value, they're pretty much asking you to find the upper fence. Okay, the lower fence in this one, the smallest. So we'll write out, if you write out, so your lower fence, let's write out the formula that I said. So the lower fence is Q1 minus 1.5 times the interquartile range, but I'm just doing it Q3. So if we pop in what we said the data was, it was 30 minus 1.5 minus 44, 30, and then we get an answer is 9. So anything below a 9 will be an outlier. Yeah, sorry. So this one, this is the answer to G, and we'll do F, sorry. Yep. So F is the upper fence one. So let's go and do that. So the upper fence is Q3 plus 1.5 times the interquartile range. So we're going to get 44 plus 1.5 times 44 minus 30. So we end up with 63. So anything above 63 is an outlier. Anything below 9 is an outlier. What? Nah. We're good now. Sorry?
65.
Oh, yeah, sorry, because I might have been a minute. Because I originally thought it was 42. Wait a minute. Is that what everyone gets? 65?
Yeah.
Yep, sorry. Let's fix that up. That's 65. Okay, example 24. All right, estimating percentages. So for the box plot shown, estimate the percentage of values. So if we look at A, less than 54. If you look at 54, what's 54 in the box plot? What does that represent? Is it Q1? Yep. So Q1 equals 54. So how much would be less percentage-wise? Would be less than Q1. Yeah, good. So remember I said that all these little sections from here is 25, here to here is 25, here to here is 25, and from there to the end is 25. So for A, less than 54 would be 25%, because that's, I'll just put in brackets because that's Q54 is Q1. Okay, if we go to the next question, B, less than 55. 55 is the median, so how many percentage is less than the median? 50%. So we'll just write, because the median is 55, yeah? Now C, what is less than 59? What is 59 to be? Yeah, Q3 is 59. So if you're going from Q3 less, how many percentage is that?
75.
Yep, 75, good. And then if you've got D greater than 59, so that would be that way. How much is bigger than the Q3? 25%. Good. And E, we have between 54 and 59. So between these two, where 54 was Q1 and 59 is Q3, how much is between that? Yep, 50% is that E answer. And then the last one, F, what about between 54 and 86? Yeah, it's going to be, because 86 is the last one, so this one's going to be 75. Okay, so we've talked a little bit about this, but now we're going to thoroughly make sure. So when we're going through describing our box plots, we do describe the shape like we do with histograms. So when you have symmetric is that it's talking about the inner boxes. So we're seeing these two are equal like size. Okay? So that's asymmetric. If you have positive skewed, you have a little one at the start and a bigger one there. Yeah? So you see this bigger tail after it. Yeah? So the one following, that would be positive skewed. If you have negative, we see the opposite. So we see that tail one, so the big long one, and a little short one. So we see that tail one at the start for negative skewed. And if you have an outlier, it'll be represented in a dot. So for this one, it definitely has an outlier. We would still describe the shape of this one here though. So what does that one look like to you? In this last one down here, what does the shape look like to me? It's got this tail bit at the start, so what would that be? Negative skewed. So this one would be would be described as negative skewed with outlier. Okay? So clutches of eggs are also being hatched in the reptile house. The box plots below show the distribution of incubation time for eggs of the species of the bearded dragon and the green iguana. So it's asking me to describe the shapes of these two. So the top one is the bearded dragon. What type of shape do we think that is? Yep, negative skewed with outlier. Good. So we need to say with or without outlier, because otherwise you don't know whether you just chanced it. Yes? Okay, so the green iguana, what type of shape is that? Positively skewed, no outliers, yeah? No outliers. Okay, so this is taken from an exam, and it says the weather station records a daily maximum temperature. The 5-number summary for the distribution of maximum temperatures of February is displayed below. And you've got to be really careful here. They say too, they help you out. There's no outliers. So you now know there's no outliers. So your maximum value is definitely your maximum, is not an outlier. So that means the whisker will go to that end. So they ask you to draw it. So this was an exam question where they're getting you to draw the box plot. So for 1 mark, you just have to fill in the dots really. So 16 will go here, yeah? And then the Q1 is 21, so I draw a line there. The median is 25. There, the Q3 is 31. So that would be my box. So I draw that. The whisker went out to there. Then we draw along here and we go up to 38, which would be here. So you draw a line up. So you do need to use a ruler. You still need to be neat. And then you would draw that. So there's 1 mark done. Just while we're here, what type of shape do you think this one is? Yeah, I think I'd go positive skewed, that one. The first box, this box, it seems a bit smaller than that box. Okay? The percentage of these 252 people, they measured the forearm circumference with less than 30. So you go up here, and 30 is my Q3, isn't it? Yeah? 30 is Q3. So they want the percentage that's less than Q3. So how much percentage goes that way? Pardon? Good, 75, isn't it? All the other bits, so there's D. Let's go. So the box plot displays the maximum temperature for both May and July. Describe the shape of the temperature, including outliers for July and May. So they did July first, so make sure you're looking at the right box plot. That's the most common error, is someone read the wrong one. So July, what's the shape of July? Yeah, I would go positively skewed with an outlier.
Yeah.
Skewed, whoops, with outlier. And then what about May? What are we going to say May is? Yeah, we're going to say symmetric. Okay, now it says determine the upper fence for July. So we want to do July. Now we know with the upper fence we're going to need the Q1 and we're going to need the Q3 of July. So Q1 of July is 8 and Q3 of July is 11. Okay, so now I've got that. I can go upper fence, I'm just abbreviating that, UF. Upper fence equals Q3 plus 1.5 times Q3 minus Q1. So that would be 11 plus 1.5 times 11 minus 8. And the upper fence ends up being 15.5. So on here, like if you went to 15.5, somewhere along there, anything above that would have been an outlier. That's why that dot, that last one, is an outlier, because it's above that. We had the amounts in dollars spent by 7 customers at a 7-Eleven store were recorded here. So it wanted you to calculate the mean and the median. So you would definitely put this in as a list in spreadsheets, and you would do the one variable like the stats and all that. So the mean ended up being, now it's set to 2 significant figures. So with significant figures, once you start have a non-zero, you start counting. So this would be 3.6. That is 2 significant figures. And if you have to find the median was 1.7. That is 2 significant figures. So does the mean or the median give the best indication for money spent? At this point, you would probably want to know what it looks like in terms of shape. And you have to, if you look down, you are asked to do a box plot anyway. But when you've already entered the list, it's not hard to go and create a box plot. So when you create the box plot, okay, so when you drop the box plot in there, you can actually see the 2 boxes look very similar. So what do we think that is? It's symmetric, yeah, with an outlier. So which is going to be a better measure of center for that? Median. Yeah, good. So we're going to say that the median is our best indication, because as the data has an outlier. Okay, so we're seeing the outlier there. So we wouldn't use the mean, so we'll use the median. It's not affected. It's a resistant statistic, not affected. Okay. It's said to calculate the standard deviation. So that's on our listen spread, when we listen spreadsheets, our stat calculations, and it's the SX value. Now it's set to 3 significant figures. So for this one, it's going to be 5.72. There's 3 non-zero numbers there, yeah? Starting with our non-zero, and then I've counted 3 numbers. So 5, 1, 2, 3. Okay, so that's that. When they ask you to calculate the 5-number summary, as I said, you should do it in order. So the minimum was 0.8, Q1 was 0.8. So with this one, it was odd. You did have Q1 is the same as the minimum value, so there's no whisker there, and you can have box plots like that, which is probably why we put this type of data there, so that you know it's possible to have that. So the median was 1.7, Q3 was 2.65 and the maximum was $16.50. E asks you to draw a box plot, so I've just dropped the calculator dump in there. So you would want to copy this, yeah? You need this number line. You need a title. So I accidentally call it amount. So we'd probably just call, if you were in the SAC, you'd write underneath amount spent at 7-Eleven, okay? Give it a proper label down the bottom. Then you would have everything in there like that. Now, because it's not super clear with your axes, you can put the 0.8 above it and, mark what they actually are. So then I can give a little bit of lenience with, maybe your scaling being a little bit dodgy. You're telling me what it is there. I like that. Okay, the next thing, it says use the test for outliers to support that the outlier in the sample. So they're saying sort of prove that it's 1650 is an outlier. So because it's an upper outlier, we would be looking for the upper fence formula. So the upper fence is Q3 plus 1.5 times Q3 minus Q1. So we've got all that data there. We've already found it. So 2.65 plus 1.5 minus, what was that one? 0.8, I think. Yep. And we end up with 5.425 is the upper fence. So therefore, any number larger than, we'll say $5.43 is an outlier. Okay, so you can write that statement. If you're proving it's an outlier, you can either write that statement or sometimes some people write like this. So 16.5 is larger than 5.425. So some people write that, therefore, and is an outlier. That's okay too, but often that's more methods kids like to write that. That'll be accepted. But writing a statement of exactly what's happening is also accepted. So you just say, well, that's larger than that, and that's okay too. Okay, so if the amount spent by each customer was increased by $2, which of the following statistics would not change? So what I did, if we added $2 to every number there, I'll write out what we would see. So we'll say this is what originally happened. Okay, so originally we had the mean was 3.6, the median was 1.7, the IQR was 1.85, and the standard deviation was 5.72. If I did the new stats with the adding the two, what we'll see is we got the mean of 5.6. So it simply added 2 to it, didn't it? So if you're adding 2 to everything, all it did was add 2 to the mean. It added 2 to the median. Now, watch the IQR. The IQR actually ends up being the same. And we get the standard deviation also ends up being the same. So it said, what did it say? Which one would not change? So we see these two not changing. And that makes sense because we've added 2 to every bit of the data. The IQR explains how the numbers range around the median. If we've added 2 to everything, we're not changing how they differ. They've all had 2, so that's going to range the same. And the same with the standard deviation, it shows you how you range around the mean. So if we've added 2 to everything, then it's still ranging around the same. So that's a case of if you're adding 2 to everything, it's going to those two would remain the same.
That means the range is the same as
Okay, so then in the next part, in, we call it H, they said that, all right, no, that wasn't the case. They then, it was just that 1650 was incorrectly entered and we wrote $16.50. Okay, so when they said, what would change here? So it depends on where that number falls back into the line. Because remember, when the median is calculated, we go in ordered lower to highest. When we change that $16.50 to $1.65, it actually slips into being smaller than the largest one, doesn't it? Because $1.70 is $2.65 is the largest. So it is going to shuffle it all around. Had it changed, if it didn't change and it was still the largest, if I made a change and it was still the largest, it would not affect the median. But in this case, it does. So sometimes you've got to be really careful and think about how it does. So once again, I've just put the new stats and we can see the originals up there. So the new stats would be that the mean now becomes 1.5. That's going to change for sure, because $16.50, now $1.65, we knew that would change. The median, well, that will depend on where it fell in. Now, because it fell in below the next value, it will change the median. So the median now is $1.65. The IQR, because those things have changed, the order, the IQR is going to change as well because it slipped in. It's not the largest value anymore. So it changed that as well. And we end up with 135 for the IQR. And the standard deviation, that would 100% change as well, because the mean, we know we calculate the standard deviation with the mean. If the mean is dramatically different, so is the standard deviation. So what ones did not change? None. They all changed. We were trying to make it, we wanted it to have one that didn't change, but we stuffed up with the data. But that's okay. Just so you know, you've got to be careful, have a think about it. If you're trying to work out a question like this and you've got a bit of data, even if you don't, chuck a list in, change one value, see what will happen, and things like that.